Welcome to this video. We are going to be dealing with superposition theorem. So we have this is our question here. We have a voltage source and a current source, and we are asked to find VA. We are labeled this is A, this is point A, this is point B. So we have to solve for voltage in A, voltage in B, then the current flowing in the 4 ohm resistor. So when we are dealing with superposition theorem, I've said it in the previous video that when you are going to take a source, use it to find what they say you should look for, and deactivate the other source. Then vice versa, to use the other source, then deactivate the previous source. So when you are deactivating voltage source, you short circuit it. When you are deactivating 5A current source, you are going to open circuit it. So here now we deactivated the current source here. That's why it is open circuited here, and this is the current source. Just focus on this red resistors, because that's what I picked from there. Every other thing there is just assumption. We are going to be using that as we are going on. So now we are using this source. Now we want to get VA, VB, and current flowing through the 4 ohm resistor. So now, without wasting much of our time, the first thing to always do is to look for the equivalent resistance. So we are looking for the equivalent resistance of all what is here. So take this 8 in relation with 12. They are in series. Whatever, when you are having an open current, an open circuit, anything after this place is useless. So just 8 plus 12. Then when these two come together here, is in parallel with 4. So just say that's in parallel with 4. Then when they are here, it's going to be in series with 5. Remember, this and this, they are in series. So when this one combines to this place, this and this will be in parallel. That's why it's in parallel with 4. Then when all of them have come here, they are now in series with this. There's nothing here again. So that's why they are going to have it like this, plus 5. So let us resolve 8 plus 12. That's 20 in parallel with 4. Then plus 5. So that will be 20 multiplied by 4 over 20 plus 4 plus 5. So let's calculate that. We are going to be having 8.33 ohms. So now we have the resistor, we have the voltage. We are going to need the current, right? We are going to need the current. Let us look for the current. The current is going to be V over R. And what is V over R? That's our V is 60 over our R, 8.33. That's going to give us 7.2 ampere. 7.2 ampere. So you have gotten the current now. That is the current that is flowing through this place. 7.2 ampere. That's the current flowing through here. That is flowing through here. So we also need, they told us in the question to get the current in 4 ohm resistor. So we have to, this current is going to split. It's going to split here and here. So now I want to use the current divider to get the current in 4 ohm resistor. So when we are doing that, just say current in 4 ohm resistor equals to the total current, which is this 7.2 multiplied by the other resistor you are using in contrast, which is 12. We are splitting here and here. Then the sum of both resistors, that's 4 plus 12. So the total of that, when you use a calculator to calculate that, current in 4 volts will be 6 ampere. So now we've gotten what is here. Here is 6 ampere. So we've gotten one of our what they say we should do for. Now calculating for the current. But before I do that, let me get the second current. When 6 current flows through here, you just have to minus it from this total to get the one that flows through here, since it's the same one that is still splitting. So now it's going to be 7.2 minus 6, and that is 1.2. That's why it's written here. So current that flows through here is 1.2. So to get our VA now, when you want to get your VA is at this point, but you are using what is before it minus what is at that point. It's just like as if you are doing BKC or KVO. So it's going to be, what is the voltage here? 60 minus the voltage here. The voltage here is what? IR. We have I, we have R. So you can just say 7.2 multiplied by 5. So when you calculate that, your VA is going to be 24. Then when you want the same thing for B2, now we have our VA as 24, and these are VB that we are looking for. So it's going to be the voltage here minus that voltage that is here. The voltage here is 24, when we got now, minus the IR, that's 1.2, open bracket 12, and that will give us in our calculator VB is 9.6 volts. So now we've gotten our VA, we've gotten our VB, and we've gotten our I, the current in 4 ohm resistor. Let's move to the second part quickly. So now this is we have used the current voltage source, so we want to use the current source now, and we have deactivated the voltage source by short circuiting it. So without wasting much of our time, let us look for the equivalent resistance. Now in this case, we are not calculating all the resistance to be equivalent. We are just taking, because we are using a current source, and we know that the current source will only split. This source is coming from here. When it reaches this place, it will split. One will go up, one will go up. So we are taking this resistor in contrast with the remaining resistors. What am I saying? What I'm saying is that it's going to be, we are going to look for the resistor of every other distance. So this in contrast with this is what? This is parallel with this. So that will be 5 parallel 4. Then if they come together, it's going to be in series with 12. So plus 12. 5 parallel 4 plus 12. Yes. So that's 5 multiplied by 4 over 5 plus 4, then plus 12. We are going to be having in our calculator 14.2 ohms. So now we are using current divider to get what is going to go through here and what is going to go through here. So now I'll just say I'm targeting this 4. This 4 I'm targeting because I need the current. So I need to first split it to this way. So when I reach here again, I will split again. So but for now, the current flowing through this 8 will be what? The total current, which is 5, multiplied by the other resistor. The other resistor is what? 14.2. You know, I told you all of this is now equivalent now. So it's what? 14.2 over the sum 8 plus 14.2. So the current for 8 ohm resistor is what? 3.2 ohms. So if 3.2 ohms flows through this place, what will flow through here? That is 5 minus 3.2, which is 1.8. So 1.8 reaches this place, and here we need to get the one that goes for 4, the current that is flowing through 4. So I'll just come here and say the current that flows through 4 will be the total current. What is the total current that reaches this place? 1.8 multiplied by the other resistor. What is the other resistor there? If this one come here to come and meet 5, so we are using 4 and 5 now. You know, one will split up here, one will come like this and come and, so this is the 5. We are using 5 and 4 in contrast. So the other resistor will be 5 over 4 plus 5. So our current flowing through the 4 ohm resistor, let me calculate it in our calculator, is going to be 1 ampere. 1 ampere. So we are getting the current flowing through the resistor, but it's not going to be 1 ampere. It's going to be negative because it's flowing up. Do we get? Well, let's leave it at that for that as at now. It's minus because it is flowing up. It's flowing from the ground, right? So that's it. So let us deal with the voltage. Let's say we've gotten this. The VA now. The VA and VB. This VA, let me insert this, is coming from down. You know, this is point A and point B, but this, you know, I said the current is flowing from below. It's a conventional flow, it's flowing from below. So we are going to be saying 0 minus VA, then the IR. Do we get? V is equal to IR, but it's flowing from the ground. So we will say IR 1 multiplied by 4. So and that's going to be what? VA will be what? Minus 4 volts. The same thing for VB too. 0 minus VB, then the current and the IR is there also. 3.2 multiplied by 8. 3.2 multiplied by 8. So 3.2 multiplied by 8, that's minus 25.6. Minus 25.6 volts. That's our VB. So now we have all what we need. we have VB, we have VA, we have I. So now you can calculate what will be your total VA, your total VB, and your total current flowing through the I4. This is where we use the algebraic sum. So what am I saying? What is the VA here? 24. Plus what is the VA here? The VA here is minus 4 plus minus 4. So that is what? 20 volts. For the VA. For the VB, what is VB here? 9.6. Plus what is the VB here? Minus 25.6. So that's going to give us what? Minus 16. Is it minus 16? Let me check. Calculate that. That's 9.6 minus. Trying to see that we don't do mistake. Yes, minus 16. Minus 16 volts. Then the last one, the current here. The current here is 6 ampere. 6 plus open bracket. What's the current in the 4 ohm resistor? Is minus 1. I told us the other time. So that's 6 minus 1, which is 5. 5 ampere. That's the current flowing through the 4 ohm resistor. So that is all what we need for this video. Thank you very much. You can see that we have gotten our VA, we've gotten our VB, and we've gotten our currents. So like, subscribe, share. This is now the end. We are still going to be dropping more exams based questions. Thank you very much.